Oh, you're back. Imagine that. Get it? Imagine that. Ha ha ha! We're talking about imaginary numbers. That's why I said imagine that. Pretty cool, huh? Okay, so we talked about adding and subtracting and multiplying complex numbers, and we talked about how to figure out when they're the same. I want to do one more multiplication for you if I have something like this, because I know you'll see something like this in the homework, and you might get scared by it. If you have this situation here, later on I'll show you another way to do this when we get to Chapter 8, but for now, let's just write it out, and then you'll FOIL it as before, and I'll actually let you finish that one. Remember that I squared is -1, okay? It's the square root of -1, No, I squared is -1, and I is the square root of -1, okay? I hate saying I is all the time. It sounds like bad grammar. Okay, another property of complex numbers that will help us with division is something called the conjugate. And basically the conjugate just means that if you have a complex number, like let's say I have 3 minus 2i, the conjugate of that is 3 plus 2i. Basically, whatever number is in front of I, you change its sign. So if it's negative, you make it positive. If it's positive, you make it negative. And the conjugate has some interesting properties. One of the properties of the conjugate is that if you multiply a complex number by its conjugate, the letter I actually drops out and you get a squared plus b squared. And I'll actually show you how to use that in a problem. So here's a division problem. And I want to take this division problem and I want to write it in standard form. So to write it in standard form, I will multiply by the conjugate of the denominator. So I'm going to multiply the top and bottom by 5 minus 4i. Okay? Now, on the top, you distribute. You know, none of that stuff has changed, even though we're dealing with I. In some ways, you treat it like a variable. So I get 20 minus 16i. And then on the bottom, I have to FOIL this, so I get 25. I'm not going to draw the lines here because it makes it kind of messy. And then outer term is going to be negative 20i. Inner term is going to be positive 20i. That's kind of fortuitous. And then the last term, 4i times negative 4i is negative 4i squared. You know, this pattern here is actually the difference between two squares, even though it may not look like it. So on the top now, I have 20 minus 16i. And on the bottom, the middle terms cancel, and this I squared is negative, so I get 25. It's going to be plus 4 is 29. And to put this in truly standard form, I suppose I should probably split it up. Sometimes you can reduce when you split it up, sometimes you can't. For this problem, I don't think I can reduce it though. So that is my final answer, and we're all very happy about that.